Hey folks, since in the last session we have understand some basic information about our data by just calling this info function. In addition to that, we have also find out this is nothing but a label distribution of our is duplicate feature, and we have also found out the total number of the questions in our data frame. That's what we have typically done with respect to previous session. So let's go ahead and try to solve some more crazy problem statement. So the first and foremost problem statement is all about, hey, can you find the unique questions in data? Again, this is typically the count with respect to all the questions. It means total questions are nothing but 404290. Now here comes the interesting thing. Now we have to find total unique questions. Again, one thing that you will notice is this length of data frame is all about, let's say, I have question 1 feature, and I have question 2 feature. It means there are total 404290 entries over here, and there are total 404290 entries here. So you can say the total question count can be nothing but a summation of both. This can be the actual count. Now you need to find the unique questions. It means this unique question can be part of either question 1 or it can be also part of question 2. It entirely depends upon our is duplicate feature. So what I can do is I can say, cool, first and foremost, let's store this Q1 feature into some list data structure, let's say L1, and let's store this Q2 feature in some list data structure, let's say L2. Once I will store it, I will say let's concatenate L1 and L2. I can say L1 plus L2. This is typically the concatenation. After concatenating, I will say, cool, let's try to create its series. Again, series is basically a data structure of pandas. Again, in pandas module, we have typically 3 data structure. The first is series, the second is my data frame, and the third is exactly my panel. This is exactly my panel. So series is basically a one-dimensional data structure. It means, let's say you have 100 features in a data set or in a data frame. So each and every feature will typically my series data structure, because it belongs to one-dimensional data structure. Similarly, on the other hand, all these 100 features are exactly my data frame. This is exactly my data frame. If I can visualize these 100 features using some 3-dimensional, we can say this belongs to panel. Again, panel is very rarely used even in context of real world. So after concatenation, we will say, hey, can I call the series on top of this? The moment I will call the series, it means I have all the data in the form of some series data structure. And we are fortunate enough that in series data structure, we have an inbuilt function, or on top of this series data structure, I can think of calling a unique function, which is nothing but an inbuilt function of my NumPy module. The moment I will call this unique on top of this, we will end up getting all the unique questions that we have. This is typically the entire strategy that we have to follow just to find the total unique questions in data. This is typically the entire strategy. So let's try to code up all the stuff, of course, using Python. So I will say df, first and foremost, let's try to access this feature. So just to convert this into list, I will call toList on top of this. Let me execute. This is typically the list notation of this feature. Now let's try to store it, let's say in L1. Let me execute. Similarly, if I will say, let me say it is all about, cool, I will say df of this one. This time it is id2. Let me execute. And just to convert this into list, I can think of calling list or toList on top of this. Let me execute. Let me store this in, let's say, in L2. Let me execute. The moment I will say L1 plus L2, let me execute. This is typically the concatenation. Let me call, let me show you one more thing. Let me call len on top of this. Let me show you that. The moment I will call len, now you can see it is all about a summation. It is all about a summation. Now I can think of calling this series on top of our L1 plus L2. Let me execute. Now this is basically a series notation of concatenation, or the series notation of our list. Now let's store this in some series. I will say it is all about QIDS. Let me execute. So if I will say QIDS, let me print it. Now let's try to call a unique function on top of this. I will say numpy dot unique, and I will just pass this QIDS. Let me execute. This will typically return an array which hold all the unique values. The moment I will call an inbuilt len function on top of this, it will return the length, which says, hey, this is basically a count of unique quotients in your data frame. Let me store this in, let's say, unique underscore QS. Let me execute and let me print it. So I will say unique QS. Let me print. This is typically the count. Let's go ahead to the second problem statement. That is all about the number of unique quotients that appear more than once. So what I will do is, in this QIDS, which is basically my series, the moment on top of this, if I will call value underscore count, just to get a label distribution or just to get a frequency distribution, the moment I will execute, you will end up getting all the stuff. It means with respect to this quotient ID, this is basically the count. It means this quotient ID gets repeated, of course, 150 plus time. This is typically what this output stands for. Now, the moment I will, let me show you one more thing. If I will say, let's copy, let's paste. If I will add a filter as, let's say, greater than 1, let me execute. You will end up getting a value as true and false. Now you can see wherever it is true, it means at such index, the count is greater than 1. That's what it stands for. So if I will say, hey, can you just do a summation of all those indexes wherever it is true, I can think of calling this some function on top of this filter. The moment I will execute this line of code, it says, hey, 111,780 is the actual count. It means there are total 111,780 quotients that appears more than once. That's what it stands for. On the other hand, our unique quotients are nothing but my 537,933. If I will try to evaluate its count in the form of percentage, so first and foremost, let's try to store this in some variable. Let's say QS underscore more than underscore 1 time. Whatever name you want to assign, it's all up to Python naming convention. Let me execute. If I will say QS, just press tab. Let me execute. Cool. Now, what I will do is I will say QS underscore more than. Let's try to divide it, of course, by unique underscore QS. The moment I will execute, and if I will say, hey, just multiply this value by 100, which basically says, it says number of unique quotients that appears more than once is exactly 20%. That's what it stands for. Now what I will do is, the second problem, the last one, not the second, the last one problem statement is all about the maximum number of times a single question is repeated. So if I will say QIDs.value counts, let me execute this line of code. The moment I will execute, you can see this is a question ID which gets repeated maximum time, which says, hey, this is the maximum count where a single question having a question ID as 2559 got repeated 150 plus time. That's how actually you can showcase this insight to your stakeholders. So that's all about this session, and if you guys have any issues regarding this session, feel free to share with us via the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.